Hello everybody. So today we are going to solve a combustion problem. So here's our problem. 1 kilomole of ethane C2H6 is burned with an unknown amount of air during the combustion process. If the combustion is complete and there are 3 kilomole of oxygen in the 3O2 in the products, determine the air-fuel mass ratio. So it says that 1 kilomole of ethane, which is C2H6, so we are going to write a chemical equation. So this C2H6, the ethane, plus the ATH, which is the stoichiometric air, then multiply by the quantity of O2 plus 3.76 nitrogen. So this quantity here makes up the air, and we're sort of ignoring all the carbon dioxide and air, considered to be composed of 21% oxygen and 79% nitrogen by volume. So this 3.76 here is obtained by dividing 79 by 21. So this quantity here makes up the whole air molecule, which is the 1 part of the oxygen and 3.76 part of the nitrogen. So, and this ATH is the unknown amount of air. So this combusts, and in the product we will add oxygen to the carbon plus the oxygen to the hydrogen. And since in the problem it is said that there are 3 kilomole of oxygen, so we will add this 3O2 in the product. Then we will add the 3.76 ATH nitrogen also. So we add a equation here below to emphasize the addition of the X and Y to carbon dioxide to the water. So we will find the value of X and Y here, and also we have here the 3 kilomoles of the oxygen, and the H here will help us determine the amount of the nitrogen produced. So we're going to balance this whole equation, and then we can balance this by looking at each element individually. So let's start first to the carbon. So we have here, we will look from the left to right. So we have here the carbon. So the carbon here is only 1. So we have here the number of moles of carbon, which is 2. So 2. Then in the right, we have here, we will put equal sign here since we are going to the product. In the right side, we have here carbon, which is only have the X value, which is unknown. So 2 is equals to X, or X is equals to 2. So next is for the H. We have here at the left, we have 6 number of moles of H. So 6 is equal to, at the right, we have here the Y and 2. So multiply 2 times Y, we have 2Y. So evaluating, we have Y is equals to 3. At oxygen, we have here in the left, we have here the 2 multiplied by ATH. So 2 ATH is equal to, at the right, we have here 2 multiplied by X, so is equals to 2X. And also we have here, for the oxygen, we have only Y plus Y. And at the 3O2, we have here 6, so plus 6. So since X and Y here has already a value, we will plug in the value. So we will now get our ATH, which is equal to 6.5. So for the nitrogen, we have here at the left 3.76 multiplied by 2, which is equal to 7.52. Distributing ATH to 3.76. So we will now have 7.52 ATH, which is equal to the multiplying 2 by 3.76, which is equal also to 7.52 ATH. So since we have now the unknown values, we will plug in this in the equation, So C2H6 plus 6.5 O2 plus 3.76 N2 will be the X is equal to 2, so 2 CO2 plus 3 H2O since Y is 3, and plus 3 O2 plus the value of our 3.76, plugging in the ATH here, so we will have to run 24.44 N2. So this is now our chemical equation, which is balanced. So since we are finding for the air-fuel mass ratio, we have here the formula of air-fuel ratio, which is equal to the mass of air is all over the mass of the fuel, where the mass of air is equal to the number of moles multiplied by the molar mass of air all over the number of moles of fuel multiplied by the molar mass of fuel. And since we have here 6.5 as our ATH, or the amount of our air times the quantity inside this, so we will put 6.5 multiplied by, since there are 1 part of the oxygen plus 3.7 part of the nitrogen, we will just add the part. So 3.76 plus 1 is equal to 4.76. Then multiplied by the molar mass of our air, which is 28.97. This can be obtained in the property table, table A-1. All over for the fuel, we have, since it is said that we have only 1 kilomole of the ethane, which is, we have this molar mass, which is 1. I mean the number of moles, which is 1, and also multiplied by the molar mass, which is 30.07 for the ethane, which also can be seen in the property table. So plugging in the values in the calculator, we will now have the air-fuel ratio of mass of our air and fuel, which is equal to 29.81 kilogram of air per kilogram of fuel.